Here we go. This will be the solution to Frappy number 2. I would like you to approach these as the way I would ideally envision it is that you guys stop this recording right now and you go and try to do this one on your own as much as you can. Even if you can't answer part A, try B. If you can't answer B, try C. If you can't answer any of them, at least maybe try to throw a fake answer with a label down there and try to salvage a couple of points. And as we start going through these and correcting them, you're going to see exactly what points get allotted and how they get allotted. So I'd really like you to stop this and go try to do it on your own. And this is a flashback to about a month ago, but my reason for doing these is to kind of keep stuff simmering even as we move on to new stuff, so that when we get to April and start doing some review, it's not like, oh my God, it's been 6 months since I've done this. So this is just kind of to keep some of this old stuff simmering in the back of your brain for a while. I'll collect it or look at it on Monday. You should have it right because I'm going to do it right now. But ideally, again, I'd like you to stop this and try to do it on your own and then come back and correct it as I tell you to, because I'm going to show you how points are allotted also. So I would stop this, go try it, and now I'm going to do it. So what you have here is a toll bridge, and they're giving you two pieces of information here. One of these charts is for the total vehicles that go through a northbound lane. And this is starting at 4 o'clock, and they say right here t equals 0 corresponds to 4, which means this is at 4, 4:30 obviously, etc. out to 6 o'clock. They're recording how many vehicles are going through at each time. And so obviously at the start there aren't any, and then at 4:30 they clocked that there were 200 that had gone through. So, and then the southbound lane, what they're doing is they're monitoring the vehicles that pass through it by estimating the rate of vehicles. So this R stands for the rate, which means this right here is 390 vehicles per hour that hour had gone through. So, but again, this is 4 o'clock, and they're doing it over rush hour, so 2 hours in would be at 6 o'clock. So my first thing is to estimate or approximate V prime of 0.75. Now this is important right here. Where did it say that it's a differentiable function? Because when we do estimates for derivatives, obviously I can't find the instantaneous exact amount because I don't have an equation or a function that's relating the values. So I can't just go use a power rule or a product rule, find the derivative, plug in a 0.75 and say instantaneously right at 4:45 there were 270 cars per. I can't do that, but I can approximate it. And whenever you're asked to approximate or find the average for a function that's differentiable, remember we said, well, what you do is you see what happens over that interval, and that's a good estimate for what happens in between. And that's exactly what we're going to do here. So we're looking for the average at 0.75, which is right smack in the middle of these two. So really what you're considering is finding the average rate of change, which is a slope, over the interval right here, from a half hour to an hour. So let's go do that. We'd say our V prime of 0.75, which is our rate of change. By the way, every time you think of that as vehicles per hour, every time you take a derivative in a real world context, you think of the word per. So I'm doing vehicles per hour, and I'm approximating at about 4:45. So what I'm going to do is I'm going to see how many cars went through 1 hour in, and I'm going to find that change over how many went through at a half hour in, and I'm going to divide that by my change in time, which is obviously a half hour, but some people would write 1 minus 0.5. Note what I'm really doing here, though, is a slope of the secant line, because what you have is at 0.5, if you were to write it as a point, there were 200 cars, and at 1, there are 425. So I'm going to do change in y over change in x, really. So I'm going to do 425 minus 200, and on the bottom, I'm going to do 1 minus a half, or this was over a half-hour interval. When I do that, I get 450. Now, always remember, don't leave naked numbers for these word problems. It needs a label. 450 what? Well, about 450 vehicles or cars per hour is an approximate for the rate at and this would be at about 4:45. 3/4 of an hour in, and it started at 4, at about 4:45. So that one's done, and that would be graded as 3 points. 1 for computation, 1 for answer, and 1 for a label with, they just said label on my thing. It didn't say that you had to explain it, but it's always good to overdo it. So that's that part. The next one is approximating the rate of change of r at 1.75. So again, I'm approximating a derivative. I'm not doing it instantaneously or exact. I don't have a function to do that. I'm going to have to go use my chart to get a good estimate of the rate of change at 1.75. And now I'm on this graph. So I'm going to go to 1.75 and I'm going to repeat the exact same process. My rate of change at 1.75 can be approximated by finding the rate of change over the interval. So again, if you want to consider them at points, at an hour and a half there are 535 vehicles per hour, and at 2 hours in, or at 6 o'clock, there are 460 vehicles per hour. So I'm going to go find the rate of change. You can see it went down, so I'm obviously going to get a negative. So I'm going to do r of 2 minus r of 1.5 divided by the change of time, which again is a half hour between these two, so I don't need to write 2 minus 1.5. When I do that, I'm going to get a 460 when it used to be 435, and that was over the course of a half an hour. And I believe when you calculate that out, I don't want to do the arithmetic in my head, you're going to get, let me find my sheet that has it on here, didn't have it near me, you're going to get a negative 150. And again, it's negative because that rate had decreased. So actually it had gone up, it plateaued, it went way up, and then it started to go down. And so that's negative 150. Now watch your labels, because it's per, every time you do a derivative. Well, this was already vehicles per hour, and now that's per hour. So it'd be cars per hour per hour. That's kind of equivalent to when we do our position and velocity. We say that our position maybe was in feet, and then our velocity, which was the derivative, is in feet per second, and then our acceleration, which is another derivative, is feet per second per second. So every time you take the derivative, you're actually finding another rate of change, adding that word per in there again. So it's decreasing. And you might even want to say hours per hour at, and that was 1.75 hours into it. It started at 4, so that would be at 5:45 p.m. And the time label on there. And again, these would be worth 3 points. 1 for computation, which would be that part. 1 for answer, which would be that part, and 1 for label, which would be this. All right, last question, and we are done. So part C, it's a lot of reading, but once you pick it apart, the math is pretty easy. It says the number of vehicles that have passed through at 6 o'clock is unknown. You'll notice if you go up there and you look at V of 2, it's empty. But it is known that the average rate of vehicles, again, every time it says that average rate of change, slope of the secant line, passing through this booth between 4 and 6 is exactly the same as the average between 4, 5, and 6. So I'm going to set them equal. So what I'm going to do is find the average rate of change between 4 and 6 first. So I'm going to find the slope of the secant line. That would be at 2 hours in, and at 4 was 0 hours in, and that was over the course of 2 hours. That'll give me the rate of change in cars over that 2-hour period from 4 to 6. They said that's the same as what happened between 5 and 6. So that's at 2 hours in, 1 hour in, how many vehicles, and that was over the course of 1 hour. So these are equal. So if I go to my chart, they didn't give me V of 2, but V of 0 was 0. You can go look at your chart, but that just means there weren't any cars when they started because they hadn't started yet. Over here, when I do V of 2, I have to go look at that one. I don't have also. I have to go look back up here and see what V of 1 is on there. Maybe I can find a sheet with it. V of 1, 425, it said. And that's over the course of 1 hour. So this is really what I've got going here, is 2 equal fractions. Now you can consider cross-multiplying, or you can use a little common sense. I'll take an arithmetic approach here and a proportion. I would have V of 2 would have to equal twice V of 2, minus 850. So when I solve this, what I get if you solve it for v of 2, which is you're missing, and some people find it helpful when they have something missing to have gone and replaced this with an x from the beginning. I think the AP graders would be fine with that as long as you interpret it at the end. So really what you're sitting with is x equals twice x minus 850, which means x is 850. So my v of 2, or the number of vehicles passing through at 6 o'clock, right at the end of rush hour, is 850. And again, it needs a label. And because I'm doing the number of vehicles per hour, I'd say vehicles or cars per hour. And you might even want to say, I think that'd be good, they would give in this one 1 point for computation, 1 point for the answer. And AP problems are always graded out of 9 points. There's 6 of them for 54 points total. The other one on this that it was, I mean, this is a guy who, you know, he worked for AP grading, but it's not necessarily saying this one's going to be on there. But it's him saying that the 9th point came from, what was it? Oh, I remember. It was for putting the actual times in there for part A and part B, for saying that it was at 4:45 and at 5:45, which is something that probably get missed. And my guess is he's just guessing about that, but there it is. You can show me that when you come in, and I would like to actually see that maybe you've corrected and tried to do it. On Monday, I think first hour, Logan's going to do Frappy number 2, and I'm waiting for volunteers for period 4 and period 6. I would love it if you could volunteer. Thanks.